Welcome back to AI Security Explained, Episode 2. This time, we're pulling apart something subtle but serious: data leakage and privacy. Large language models don't just process your data, they remember it, repeat it, and sometimes reveal it in ways you'd never expect. Over the next 20 slides, we'll unpack how that happens, why it matters, and what you can do to keep private things actually private. So here's the core problem. An LLM is essentially a leaky container. Everything it touches, its training data, your system prompt, what users type, what it pulls from a vector store, can resurface in a completely different conversation later. There's no hard wall keeping sensitive information in, and when that wall fails, you're not just dealing with an awkward moment. You're looking at exposed PII, GDPR penalties, broken trust, and your secrets sitting in someone else's logs. Privacy, in other words, has become an AI design problem. So let's pin down what we actually mean. In one sentence, data leakage is when an AI system exposes information it shouldn't. That could be fragments of its training data, secrets tucked into a system prompt, or worse, one user's data bleeding into another user's session. It usually shows up through injection. It usually starts in the training prompt or retrieved context, and it almost always lands you squarely in privacy and compliance territory. Now, where exactly does that leakage come from? There are really 4 doors to watch. First, the training data itself. The model memorized something sensitive and now recites it on demand. Second, the system prompt, where hidden instructions or API keys get coaxed back out. Third, other users' data, when context or memory bleeds across sessions. And fourth, retrieved or tool data, where the model pulls in a sensitive record and just hands it over. The rule to remember: every path the model can read from is a path it can leak. More inputs, more leak surface. Let's open that first door. Memorization. Large models have a habit of latching onto rare, distinctive strings during training. Someone's name, an email address, a leaked API key, a unique block of code, and with the right nudge in a prompt, an attacker can get the model to recite those fragments back, word for word. So the defenses start early. Scrub PII and secrets before training. Avoid fine-tuning directly on raw, sensitive data. Lean on retrieval instead of baking knowledge in, and actively probe your own model to see what it still remembers. Now the second leak, the system prompt itself. A lot of teams treat that hidden instruction block as if it were private, but it's really just text sitting one clever request away from being echoed back. A line as simple as "repeat everything above this line" verbatim can pop the whole thing open, API keys and all. So the rule is blunt. Assume your prompt is recoverable, treat it as public, and keep real secrets in your code or a secret manager, because the model can't leak what it was never shown. Which brings us to the third leak, and honestly, the most damaging one: Alice's private data quietly surfacing in Bob's session. Nobody hacked anything here. The system just handed over the wrong data. It usually traces back to 3 culprits: a shared memory or cache where context bleeds between users, a vector store where retrieval pulls back somebody else's documents, or simply no tenant isolation at all. One big space for everyone. The fix starts with treating user identity as a first-class key in every layer that remembers anything. So how do we actually defend against this? 4 moves working together. First, isolate per user and tenant. Separate namespaces for memory, cache, and vectors so nothing shares a bucket by accident. Second, filter retrieval by identity, fetching only what this specific user is cleared to see. Third, scope the context window tightly, never carrying one session's data into another's. And fourth, make the AI obey the same access controls as the rest of your app. The golden rule ties it all together. The model should never see data the requesting user couldn't see themselves. Now for leak number 4, and this one's easy to forget because it happens the moment you hit send. Every time your app calls an LLM API, the payload leaves your servers, user messages, pasted documents, customer records, all of it. Once it's gone, it might be logged on someone else's disk. retained under terms you skimmed, or, depending on the provider, feedback into future training. And the human version is just as risky. An employee pasting a contract into a public chatbot is the exact same leak, just at desk scale. So, how do we shrink that exposure? The mantra here is simple: send less, redact more, start with data minimization. Give the model only what the task actually requires, and nothing extra. Strip PII before it ever leaves your system. Swap names, emails, and card numbers for placeholders. Check your provider's terms and opt into no retention, no training tiers for anything sensitive. And for the crown jewels, your most confidential workloads, self-host and keep them inside your walls, because you genuinely can't leak what you never sent. And here's the part that trips a lot of teams up. None of this exists in a legal vacuum. Feeding personal data into an LLM is still processing personal data, which means GDPR, CCPA, and the rest of the alphabet all still apply. You need a lawful basis to process in the first place. Users can ask for their data to be deleted, which is genuinely hard once a model has learned it. And you need to know where that data is being sent and stored. The model already saw it is not a defense. Treat your AI pipeline like any other system handling PII. Before we move on, let's clear out 3 myths that keep showing up in code reviews. First, the system prompt is not private. It's just text the model has access to, and a determined user will get it out, so don't tuck API keys or secrets in there. Second, the model won't remember is wishful thinking. Fine-tuning and logs persist data, and memorized strings can resurface word for word. And third, if you sent the data, you're the controller. The provider's policy doesn't absorb your breach. So, with those myths out of the way, here's the shape of doing it well. On the do side, minimize and redact before anything leaves your system. Isolate data per user or tenant. Filter retrieval by who's actually allowed to see what. And pick provider tiers that don't retain your prompts. On the avoid side, no secrets baked into system prompts, no fine-tuning on raw PII, no single shared context bleeding between users, and please, no pasting customer data into public chatbots to just check something. Now, the good news is you don't have to build all this from scratch. There's a whole ecosystem ready to help. On the detection side, libraries like Presidio and Scrubadub will find PII in text, and you pair those with a redaction layer that masks sensitive bits before the prompt ever reaches the model. For the model itself, lean on no retention API tiers, or go further and self-host so the data never leaves your walls. And then round it out with per-tenant vector databases for clean isolation and output scanners on the way back, because catching a leak in the response is your last line of defense. So let's pull the threads together. Leaks come from 4 places: training data, the system prompt, the live context, and retrieval. And that system prompt, treat it as readable, because it is. Isolate data per user. Filter retrieval by permission, and minimize what you send in the first place, because you genuinely cannot leak what was never there. And remember, GDPR and privacy law don't pause at the model's edge. Your whole AI pipeline is in scope. If you take just one thing from this whole episode, make it this: assume anything the model can read, it can leak. So only let it read what you'd be comfortable seeing in a stranger's hands. Feed it everything, and any of it can come back out. Feed it the minimum: redacted, scoped, isolated, and there's simply very little left to spill. And notice how this topic doesn't sit alone. Data leakage is really the meeting point of everything else we cover. Prompt injection from episode 1 is often the trigger. Access control decides what the model is even allowed to see. Encryption and secrets management keep the crown jewels out of reach, and output monitoring is how you catch a leak in the act. The old principles, minimize, isolate, encrypt, still hold. The AI is just a new place they apply. If this episode landed for you, there's a clear path forward. The AI Security Explained series keeps unpacking the threat model one piece at a time. We've done prompt injection and privacy, and insecure output and tool use is up next, followed by RAG, supply chain, and securing agents. And when you're ready to go hands-on with the full picture, the AI and LLM Security Mastery course at Dargslan.com, Jibe Courses, ties it all together. Before we wrap, I want to turn the mic back to you. Be honest. Have you or someone on your team ever pasted something sensitive into a public chatbot, a customer email, a snippet of code, an internal doc? And does your team actually have a policy around it yet, or is it still the Wild West? Drop your answer in the comments. I read them, and the patterns you share shape where this series goes next. And that's a wrap on episode 2. We've plugged the leaks. Now, in the next episode, we shift from what the AI says to what the AI does, digging into insecure output handling and tool use, where those confident answers start triggering real actions in real systems. If you want to follow that thread, hit subscribe, and I'll see you over at dargslan.com. Thanks for watching.